in our next section of this unit on radicals. First thing we're going to do is review an equation clear back from chapter like 1 or 2 where we solved the multi-step equation. So first of all, we want to use the distributive property to get rid of the parentheses. So we multiply the number out front by each number inside the parentheses, and we get 6x minus 10 plus 7 equals 21. All right, so now I'm going to collect the like terms. So I've got a 6x on the left side, and everything else is a constant. So we have 21 on the right side, and that minus 10 is going to move to the other side and become plus 10. And this plus 7 is going to move to the other side and become minus 7. So when you do 21 plus 10, that ends up being 31. So we end up with 31 minus 7, and 31 minus 7 equals 24. So we end up with 6x equals 24, and I think you can tell right away, if I divide both sides by 6, I get a final answer of x equals 4. All right, so we just wanted to review these from time to time so you don't forget how to do them. So today we're going to talk about simplifying radicals. We often simplify radicals to write them in a more understandable way and without those crazy decimals. Now we mentioned before that if you take the square root of something like 2, you end up with a decimal that goes on forever and never repeats or terminates, and it's irrational. Well, we want to find a different way to write those so that we don't have to write those decimals, but we can write it in a more understandable and simple way. So first off, what we are going to do is kind of factor tree the radicand, which is the number underneath the radical. Then any factor that has a pair we take out, or when we say a pair, we mean a perfect square. We take one outside the radical. Leave any factor without a partner inside the radical, and then simplify it from there. So let's show you a couple ways to go about doing this. So let's look at our first one. So we have the square root of 18. This breaks down into 2 times 9. And 9 further breaks down into 3 times 3. So essentially what we're doing at this point is taking the square root of 3 times 3, which is 3, and we put it out front, and the square root of 2 is left over inside. So there's our final answer. So let's try another one. Let's do the square root of 12. Now this one I've written a little bit differently. If I break this down, 12 breaks down into 4 times 3. And I know that 4 times 3 is a perfect square. It's just 2 times 2. So remember how we said if you have a pair, you can take one out, which means you're taking the square root of 2 times 2, and that is just 2. So our final answer is 2 times the square root of 3. All right, how about the square root of 32? This one's a little bit more interesting, a little bit bigger. So let's check this one out. So I noticed that if I break this down, I just happen to know off the top of my head that 32 is 16 times 2. And 16 happens to be a perfect square. It happens to be 4 times 4. So I already have a pair of factors that are sitting right there. And rather than breaking those down into 2 times 2 and 2 times 2, I'm just going to take the square root of that number, which is 4. So I take one of those 4s out because I took the square root. I'm left with 4 times the square root of 2. All right. Let's look at one that's pretty complicated, and you won't see anything bigger than this. And so, in fact, this is going to be kind of one of the biggest possible ones you'll see, and I'll work this one for you. So square root of 512, well, that would be 2 times the square root of 2 times 256. Well, let's keep breaking it down. 2 times 2 times 128, and 128 breaks down into 2 times 64, and 2 times 64 breaks down into 2 times 32, and 2 times 32 breaks down into 32 breaks down into 2 times 16, and 16 breaks down into 2 times 8, and 8 breaks down into 2 times 4, and finally 4 breaks down into 2 times 2. Well, if we notice, we've got 1, 2, 3, 4 pairs of 2s, and so we are going to take one of each of those pairs of 2s out front. One from the yellow, one from the green, one from the blue, one from the pink. We're basically taking the square root of 4, 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 and all of those are 2s. Now, when we multiply 2 times 2 times 2 times 2, what do we get? We get 16. So our final simplified radical is 16 times the square root of 2. All right, let's do a few more, and maybe I'll do these just a little bit differently. It might make it a little bit easier. Let's just keep using the arrows and the numbers before we put that radical sign back on there. So 18 breaks down into 2 times 9, and that breaks down into further 2 times 9, or 2 times 3 times 3. So I notice that the factor I have a pair of are the 3's. So I will take one of those outside and out front, and that will become just 1 3. And what's left under the radical is this sign right here. So I'm taking one of these 3's out, and the 2 is left inside. So there's my simplified radical. How about 8 times 10? Well, let's see. That would be 2 times 40. And that'll break down into 2 times 20. Keep going. We got 2 times 2 times 2 times 10. Looks like we're almost there. 2 times 2 times 2 times 2 times 5. And that's as far as we can go. So you need to imagine that we've got a radical there. And we've got a pair of 2's and a pair of 2's. And if I take one of that pair of 2's out front, and one of this pair of 2's out front, and I'm left with just 5 left in the radical. And what is 2 times 2? Well, you're right, it is 4. So my final simplified form is 4 times the square root of 2. All right, so let's try the square root of 176. Hopefully we've got enough room to do that one. So let's take a look. We've got 2 times, and then half of 100 is 50. 2 times 35. So that's going to be 85, 86, 87. So this is going to be 88. 2 times 88 is 176. Well, if we keep going a little bit further, that's going to be 2 times 2 times 44. And then that's going to keep breaking down into 2 times 2 times 2 times 22. And we're finally to our last step, 2 times 2 times 2 times 2 times 11. So when I take one of each of these out in front of the radical, that's going to leave me with 2 times 2, which is 4. And what's left inside is going to be this 11. So I'll have 4 square roots of 11 on this one. And that's what we mean by writing as a simplified radical, or simplified radical form. So as you can see that we don't have any messy decimals or, non-repeating, non-terminating decimals. We can just kind of simplify the radical down a little bit further. So I know this is going to be a little bit of a challenge, but we're going to give it to you on a worksheet this time. So good luck on it. And if you need any help, let us know, and thank you very much.